Spin launch launches small and crude spacecraft into low Earth orbit without the use of rocket fuel. Elon Musk sends the first Starship to Mars, preparing the ground for the Red Planet's first explorers. NASA's Artemis mission launches to begin building a permanent habitat on the Moon. The first humans are traveling from Earth to the Red Planet aboard a Starship from SpaceX. Astronauts traveling to Mars use virtual reality goggles to help them stay calm. During the 7-month journey, humans begin interacting with artificial life, virtual reality, and living creatures in a digital world that learn to act, move, and interact with humans on their own, creating their own behaviors and lifestyles. Testing begins on the first small-scale nuclear fusion spacecraft, which produces energy without nuclear waste. The fuel is hydrogen. Hydrogen is present in the atmosphere of many planets and on asteroids. Nuclear fusion requires an environment similar to the center of the Sun, with extremely high temperatures and pressures. It is the gravitational forces of the Sun that compress the hydrogen at the center, creating nuclear fusion. On a spacecraft, fuel is heated to plasma and then compressed either by magnetic confinement in the form of large electromagnets or by inertial confinement using lasers and pistons to push and squeeze the fuel. A few kilograms of fuel can power an average home on Earth for about 9 years. And for a spacecraft, fusion energy would cut future flight times in half. And an advanced ultra-high energy fusion engine could soon be able to get a spacecraft to Mars and back in 45 to 75 days rather than 7 months. Tiny spacecraft equipped with lightweight sails and powered by lasers on Earth are sent into space. They travel at speeds up to 20% of the speed of light. The purpose of these tiny craft is to circle and collect data from the exoplanet Proxima Centauri b, which is an habitable zone for human life of the star system. Humans live on the Moon on research stations, acting as a link between Earth and Mars and the outer solar system. A space station built in the orbit around the Moon begins operations. Technology development begins to create large-scale electromagnetic dust shields to protect habitats from dust storms. SpaceX begins launching the basic elements of an orbital fuel station. The era of orbital refueling begins. Cryogenic propellant is stored, and soon mechanical spare parts for spacecraft will be stored, allowing spacecraft to be serviced and repaired in Earth orbit without landing. Spacecraft are thus divided into two types. Those designed to launch and land on Earth with additional heat shields, fuel storage, air brakes, and parachutes, and those designed to operate only in the vacuum of space. While SpaceX's fuel station is under construction, it's also testing working prototypes of starships that are twice the diameter and 4 times the interior space of the first-generation Starship, which is large enough to become a space station itself. The Interplanetary Internet System is launched, creating the first computer network in space. The network consists of landing robots, planetary satellites, and ground stations. A Jupiter rover sends data to a Jupiter satellite, which transmits it to a Mars satellite, which then relays it to Earth. Factories are being set up on Mars to produce 3D printed habitats. Other robot factories produce water and oxygen and lab-grown plant and meat products in time for the arrival of new explorers and scientists. The first guests arrive at the former International Space Station, which has been converted into a luxury orbital hotel, while the new commercial International Space Station is used for scientific research. In space, Starlink, SpaceX's company for Earth, is fully operational. Along with this, filming begins on the first Hollywood blockbuster shot entirely outside of Earth, using sets and locations in Earth orbit and the Moon. Over time, more and more people will view the Red Planet as a second home for humanity. The first park opens on the Moon, with 2 small artificial lakes, Earth plants and trees, and space for animals, making it the first space zoo. It's been 5 years since Mars had its own internet. The square-kilometer array has been launched. The dishes located in the deserts of South Africa and Australia are 50 times more sensitive than the Hubble Space Telescope and can pick up even the faintest radio signals from any potential extraterrestrial civilization. Lunar habitats begin printing on the Moon. Their advantage is that the materials they're made of absorb solar radiation and micrometeorite impacts, converting solar and impact energy into electrical energy. The building of spacecraft on the Moon for further exploration of the solar system begins. This is followed by the launch of the 1000th Starshot Alpha Centauri program, founded by Yuri Milner, Stephen Hawking, and Mark Zuckerberg. Asteroid capture operations begin. Robots controlled by artificial intelligence capture asteroids from the asteroid belt and maneuver them into orbits of the Moon and Mars. Raw materials are taken to Mars and the Moon to be processed into materials for further construction of extraterrestrial habitats and space exploration. Construction begins on the largest rotating spaceport on Earth's orbit, which some people call a garden in space. The wheel-similar structure with a rotating outer ring that creates artificial gravity can accommodate 450 people, including scientists and tourists. A museum on Earth displays a painting made on the Moon using lunar dust. A private lunar hospital is conducting research into advanced low-gravity medical care on Mars. On Earth, the science of biological 3D printing of human tissues and organs is being commercialized to enable advanced medical procedures to be performed beyond Earth, and the development of exoskeleton technology allows humans to live in low gravity. The need for asteroid defense has increased as humans already have 3 colonies on Earth, the Moon, and Mars. At this point, there is a mass migration of people from Earth to Mars, and 200 Starship rockets launch from Earth's orbit heading for the Red Planet. People disillusioned with life on Earth can find a sense of hope elsewhere in the solar system. Successful missions to Mars set the stage for future human colonization of the outer planets of the solar system, encouraging companies to invest in reusable spacecraft and autonomous mining technologies. Before we can establish permanent human settlement on the satellites of Jupiter and Saturn, we'll need billions or trillions of dollars and incredible amounts of energy. Meanwhile, there are 300,000 people living on Mars. A meteorite from the asteroid belt has been excavated from beneath the surface of Mars. It contains microbes, which is strong evidence of panspermia. Soon after, a research robot detects microbes in the near-surface ocean on Jupiter's moon Europa. Any discovery of complex multicellular life in Europa's oceans will revolutionize humanity's understanding of biology. People wonder if this will be the beginning of a domino effect in a discovery of life in the universe. Laboratory tests begin on a scale model of a spacecraft capable of generating a magnetic field that deflects charged particles and protects the vehicle from space debris, and artificial intelligence engineers have prepared the first AI capable of single-handedly controlling an entire spacecraft. It's capable of autonomous mission execution, self-determining goals and objectives, and creating new missions. Humans can make weekly trips, taking shuttles to the space stations where they work and returning home for the weekend. There have been public shuttles with daily schedules. Electric ion engines, which create thrust by electrically charging gas, become increasingly powerful and are used to power the Lunar Gateway space station. Humanity watches the construction of ever larger space structures. Rockets launch expendable and inflatable payloads. One launch sends an entire space station into space. The space station is placed around one of Jupiter's satellites, Ganymede. It's the largest moon in the solar system. With its own magnetic field and underground ocean, it'll be mankind's deepest outpost in outer space. Astro engineers work on large-scale designs for interstellar structures and systems. Bioastronomers investigate the past, present, and future existence of life in the universe, and exoclimatologists study climate and weather patterns on planets beyond our solar system. Lunar archaeologists discover the remains of Apollo and Artemis-era missions, and lunar fashion, inspired by practicality of spacesuits, becomes fashionable on Earth. More and more spacecraft and habitats are being built using transparent aluminum. Earth-based astrogenetic scientists work to create bioengineered animals that can survive in low gravity. When these animals are transported to the Moon, they will create the first multi-species space colony in history. A space telescope detects a strange industrial signature in a distant star system. An industrial signature is defined as any sign or evidence of industrial activity, especially related to the production or use of energy. Mankind wonders if the telescope has detected an anomaly or evidence of energy production by another civilization. The first person is put into sleep mode. Body temperature drops to 32-34 degrees Celsius or 89-93 degrees Fahrenheit. Heart rate decreases, metabolism slows to almost a complete halt, oxygen demand decreases, and even aging slows down. Calculations show that even for a small crew of 4 to 6 people, the mass of the habitat, that is the necessary supplies, equipment, and living quarters, is reduced by 70 to 90%. This kind of hibernation is made possible by advances in inducing torpor, a technique that replicates mammalian hibernation. Once in the capsule, the astronaut doesn't feel cold. The temperature is slowly changed, and he is injected with a drug that induces a state of torpor. The goal of the project is to create deep space spaceships with chambers filled with these numbness-inducing containers called hypersleep capsules. Humanity begins to dream of space structures of limitless dimensions. On Earth, it's announced that humanity has officially become a multiplanetary species. Orbital mechanics is taught in high schools along with space law. A space Creole language is already forming. Words borrowed from Earth languages are used to describe the new alien experience of living in space. Replicants are being sent to other planets. These self-replicating microbots are programmed to terraform, slowly transforming the planet's atmosphere. They use the planet's resources to self-replicate and reproduce, equipped with high-density DNA memory to remember their terraforming instructions. 1 gram of DNA can store 215 petabytes of information, similar to cells and bacteria. Advances in second-generation quantum computing make it possible to create a detailed map of the galaxy. The map also contains predicted locations of possible wormholes. An advanced quantum computer system is being used to create yet the most detailed simulation of a black hole, providing the first evidence of the existence of other dimensions. Theoretical research is being conducted in the world of exotic energy sources to find higher Kardashev levels of energy generation. These studies include the manipulation and control of gravitational fields, vacuum energy, dark matter, and dark energy, which is a mysterious form of energy that is the driving force behind the accelerating expansion of the universe. A neutrino detector built on the far side of the moon allows humanity to gain a deeper understanding of the inner workings of stars and the sun. A new supermaterial capable of withstanding the extreme conditions of Venus has been developed, allowing robotic missions to be planned to the solar system's hottest planet. Terraforming researchers show Earth's inhabitants the concept of a realistic floating space cloud city. Venus's upper atmosphere has more similar conditions to Earth's, and a successful station here could become a model for future air colonies on gas giants, such as Saturn, Jupiter, and others. Mars declares its independence from Earth. Robotic transit fleets deliver materials across the solar system and in the vacuum of space. NASA's Alcubierre space warp drive has begun to work. Nothing can travel faster than the speed of light, but it uses negative energy to warp space-time. The space behind the spacecraft expands, and the space in front of it contracts, forming a warp bubble, warping space-time around the spaceship and breaking the speed of light. Humanity is declared a Type 1 civilization. By 2250, virtually all of Earth's natural energy has already been harnessed or captured. Solar, wind, hydroelectric, and geothermal technologies are being used to create vast amounts of energy over vast areas of the Earth. Thermonuclear fusion of water and antimatter are being used to create vast amounts of energy. In addition, entirely new forms of energy generation unknown in previous centuries are being used to orbit the Earth. There is now an extensive network of energy capture vessels. They are organized to collect every ounce of incoming solar radiation reflected from the Earth into space. Each ship is a node in a giant network that completely girdles the planets. Between the nodes, an invisible shield is formed that absorbs solar radiation from all corners of the planet. In addition, this invisible shield stabilizes the Earth's climate. At certain points on Earth, this shield can be adjusted to control the amount of solar heat. As a result, rain can fall where and when it's needed. While hurricanes and tornadoes can be easily controlled, the vast amount of energy now available to humans creates tremendous wealth, prosperity, and technological advancement. With the increased amount of energy and the availability of the latest replicator machines, all material needs are almost completely eliminated. As of now, the only way for human civilization to get more energy is to get it directly from the sun and go into space. An interstellar ship is built and launched to the nearest habitable exoplanet. But only robots are on board, and the journey will take generations. Life has been discovered on other planets thanks to probes equipped with antimatter engines. Dozens of neighboring star systems have been explored. After surveying thousands of planets, automated probes have discovered a cellular organism within 100 light-years of our solar system. As expected, this lifeform reproduces by binary fission. Its internal chemical structure is strikingly similar to DNA. This may indicate that this lifeform is quite common in the universe. The planet it inhabits contains liquid water, and its distance from its star makes it suitable for life. In addition, there are gas giants in the outer part of its star system that protect it from passing comets. The entire solar system is populated by humans. Earth's moon is now the most populous of all space colonies. Millions of people live there permanently. Mars is densely populated with cities connected by a network of super-fast automated railroads. Both Mars and Venus undergo massive terraforming efforts. Asteroid mining brings people the greatest income in the inner solar system. Thousands of asteroids are being mined at a time. Meanwhile, metals, minerals, and ice are being mined on Jupiter's moons. Around Saturn's rings now revolve luxury hotels that offer magnificent views of this massive gas giant. Guests can step outside these hotels and drift among the slow-moving shards of ice and rock in Saturn's rings. Saturn's largest moon, Titan, is now home to entire cities. Enceladus is another moon of Saturn that has an ocean of liquid salt water beneath its icy crust. It may serve as a source of water for human civilizations in the outer solar system. Even planets as distant as Uranus and Neptune already have gas miners, and development is expected to increase dramatically in the coming decades and centuries. The Kuiper Belt is a region of the solar system beyond the orbit of Neptune that contains more than 1 trillion comets, asteroids, and other small objects composed mostly of ice. Dyson structures are being built in orbit to capture energy from the sun. With more energy at their disposal, humans will be able to create technologies that used to be synonymous with science fiction, such as the molecular assembler, a nanomachine that manipulates atoms and can create objects using molecules. Combined into highly efficient systems, or so-called nanofactories, these hypothetical machines will be able to create almost anything, and will bring our species into an era of radical abundance. The colonization of worlds around distant stars begins. Beautiful future, isn't it? What'd you think about it? Write your opinion in the comments and subscribe to our channel. If you like this video, we recommend you to watch our detailed video about how people will colonize the moon as well as Mars.